let's learn to use vectors to, or let's learn to use diagrams to add vectors together. Here's a true story. When I was young, I wanted to see South America, so I went to Peru. And on my first day in Lima, I got lost walking around the city. And I had only very basic Spanish language skills, so although I could ask for directions, I could not understand the answers that were given to me. But luckily, when you ask someone for directions, they typically point in a specific direction. So I just pretended to understand, and then I walked in that direction that the person had pointed to for a few blocks, and then asked again. Okay, let's retrace Mr. Schmidt's steps around the city. And here we have a series of displacements. So we're going to travel 2 blocks north. This is delta x1. Then we'll travel 3 blocks east, delta x2. Then 1 block south, delta x3. 1 block west this way, delta x4. And 2 blocks north. Here we go. Okay, that is a delta x5. Then 2 blocks east again. Delta x6, 3 blocks south. Delta x7. And finally 2 blocks east. Delta x8. Okay. Okay, now the next question is, what is the distance? What distance did I travel? Well, distance is a scalar, and we're familiar with scalar addition, so it's just 2 plus 3 plus 1 plus 1 plus 2 plus 2 plus 3 plus 2, and you got 2, 5, 6, 7, 9, 11, 14, 16 blocks. So I walked 16 blocks that day. But then if we figure out what is the displacement, that is, when you add these vectors together, how far and in what direction did I actually travel? Where did I change my position to? Well, I started here and I ended up here. This is my finish, right? So this is the result of this walk, right? And you can see that the sum of these vectors, right, delta x1 plus delta x2 plus dot 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 plus delta x8, these are all vectors, equals, let's count it, 2, 4, 6 blocks east. All right, I just answered this question. Let's put this down here. Okay, so that is the difference between scalar addition and vector addition. On the next page, we'll practice vector addition, but to do it, you generally need a diagram, and you arrange the vectors such that they are aligned head to tail. The vector x2 is attached to the head of vector x1, and so on. All these vectors are lined up head to tail, and the sum of those vectors extends from the tail of the first vector to the head of the last vector. Okay. All right. Let's read this paragraph together. In the above example, direction was specified with a cardinal point, so east, west, north, south. Once a direction is specified, for example, north or up or left or right, we can use the positive sign. Right? Put a positive sign here to specify towards that direction, and the negative direction or the negative sign to specify in the opposite direction. So if I want, so I could have written -6 blocks west. When you say a word like west, you are telling the reader that west is the positive direction. And when you say a word like east, you are saying to the reader that east is the positive direction. Okay, so when I say positive 6 blocks, east is the positive direction. That's why I put positive 6 here. And it's the same thing as negative 6 blocks in the west direction. Okay, we often use east, north, up, and right as positive, and by convention, we often use west, south, down, and left as negative. But it's not always the case, right? For instance, if you were to say to somebody, if somebody asked you, where is the center of the Earth? You could point downwards, and you could say it's 6,380 kilometers down, right? In that case, down becomes positive.